Gravitational wave researchers cast new light on Antikythera mechanism mystery. This is an ancient computer type of thing. Astrolabe, found in the year 1900, just off the coast of the island of Antikythera in the Aegean Sea of Greece. Techniques developed to analyze the ripples in space-time detected by one of the 21st century most sensitive pieces of scientific equipment have helped cast a new light on the function of the oldest known analog computer, this Antikythera mechanism. Astronomers from the University of Glasgow have used statistical modeling techniques developed to analyze gravitational waves to establish the likely number of holes in one of the broken rings of the Antikythera mechanism, an ancient artifact which was showcased in the movie Indiana Jones, The Dial of Destiny. And while the movie version enabled the intrepid archaeologists to travel through time, the Glasgow team's results provide fresh evidence that one of the components of the Antikythera mechanism was most likely used to track the Greek lunar year. They also offer new insight into the remarkable craftsmanship of the ancient Greeks in making this thing. The mechanism was discovered in 1901 by divers exploring a sunken shipwreck near the Aegean island of Antikythera. That's south of the Peloponnese, by the way. Although the shoebox-sized mechanism has broken into fragments and eroded, it quickly became clear that it contained a complex series of gears which were unusually intricately tooled. Decades of subsequent research and analysis have established that the mechanism dates from the 2nd century BC and functioned as a kind of a hand-operated mechanical computer. Exterior dials connected to the internal gears allowed users to predict eclipses and calculate the astronomical positions of planets on any given date with an accuracy unparalleled by any other known contemporary device. In 2020, new X-ray images of one of the mechanism's rings, known as the calendar ring, revealed fresh details of regularly spaced holes that sit beneath the ring. Since the ring was broken and incomplete, however, it was not clear how many holes were there originally. Initially, analysis by Antikythera researchers Chris Butyselic and colleagues suggested it was likely somewhere between 347 and 367. And now in a new paper published by the Horological Journal, the Glasgow researchers describe how they used two statistical analysis techniques to reveal new details about the calendar ring. They show that the ring is vastly more likely to have had 354 holes, corresponding to the lunar calendar, than 365 holes, which would have followed the Egyptian calendar. The analysis also showed that 354 holes is hundreds of times more probable than a 360-hole ring, which previous researchers had suggested as the possible count. Professor Graham Wowan of the University of Glasgow School of Physics and Astronomy is one of the authors of the paper. He said, towards the end of the last year, a colleague pointed to me to data acquired by YouTuber Chris Butyselic, who was looking to make a replica of the calendar ring and was investigating ways to determine just how many holes it contained. It struck me as an interesting problem, and one that I thought I might be able to solve in a different way during the Christmas holidays, so I set about using some statistical techniques to answer the question. Professor Wowan used a technique called Bayesian analysis, which uses probability to quantify uncertainty based on incomplete data, to calculate the likely number of holes in the mechanism using the positions of the surviving holes and the placement of the ring's surviving 6 fragments. His results showed strong evidence that the mechanism's calendar ring contains either 354 or 355 holes. At the same time, one of Professor Wowan's colleagues at the university's Institute for Gravitational Research, Dr. Joseph Bailey, had also heard about the problem. He adapted techniques used by their research group to analyze the signals picked up by the LIGO gravitational wave detectors, which measure the tiny ripples in space-time caused by massive astronomical events, like the collision of black holes as they pass through the Earth to scrutinize the calendar ring. Can you imagine? The Markov chain Monte Carlo and nested sample methods Warren and Bailey used provided a comprehensive probabilistic set of results. Again suggested that the ring most likely contained 354 or 355 holes in a circle of radius 77.1 millimeters, with an uncertainty of about 1/3 of a millimeter. It also revealed that the holes were precisely positioned with extraordinary accuracy, with an average radial variation of just 0.028 millimeters between each hole. Bailey, a co-author of the paper, is a research associate at the School of Physics and Astronomy. He said previous studies had suggested that the calendar ring was likely to have tracked the lunar calendar, but the dual techniques we've applied in this piece of work greatly increase the likelihood that this was the case. It's given me a new appreciation of the Antikythera mechanism and the work and care the Greek craftsmen put into making it. The precision of the holes' positions would have required highly accurate measurement techniques and an incredibly steady hand to punch them. Professor Wan asked, "It's a neat symmetry that we've adapted techniques we use to study the universe today to understand more about the mechanism that helped people keep track of the heavens nearly 2 million years ago, 2,000 years ago. We hope that our findings about the Antikythera mechanism, although less supernaturally spectacular than those made by Indiana Jones, will help deepen our understanding of how this remarkable device was made and used by the Greeks." This is by University of Glasgow. And again, I ask you, why would they want to know how the constellations moved around us? What would be the use of that? And I asked my son, my eldest son, this. I said, "Why do you think they made the Antikythera device?" I said, "Mom, they had nothing better to do." I said, "What, are you kidding me?" I said, they had nothing better to do than calculate the exact, time of the eclipse into God knows how many thousands of years in the future, or how the constellations, run around us, and exactly when and where. I mean, obviously, to me, I believe that they had very advanced knowledge of astronomy, and they wanted this to figure out when the constellations were moving when, because of the fact that they had flight. They had as the Homer in the Odyssey explains, they had the knowledge of flight. Let's remember that ancient Greeks also were commissioned, the engineers were commissioned by India to construct vimanas, spaceships, that is. Okay? This is Atlantean technology. Even the ancient Greeks believed that the gods of Olympus were Atlantean extraterrestrials. So there's a lot of questions to be answered concerning this thing. And I believe that they needed to know exactly how the constellations moved, because they had to keep track of the stars around them and galaxies, because they had interstellar travel. Please leave your comments about this. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.